All right, guys, today we're going to look at scientific notation, standard notation, and decimal notation. So make sure you have your form open and your video ready to go. Your form and your attendance. That's the word I'm looking for. All right, let's continue. So for your warm-up, you're going to use your calculator to solve. 3 groups of students use different methods to estimate the diagonal length of a patio in feet. Their results were 4 times the square root of 13 feet, 14 and 2/5 feet, and 14 and 33/100 feet. Which list shows these diagonal lengths in order from greatest to least? So make sure you use your calculator. I typed in 4 times the square root of 13 and I got 14.42. I rounded it. Then I did 2/5 and I got 4/10. So this would become 14.4, and I added a 0 so that the same amount of numbers after the decimal place are there. Now if I put these numbers in order from greatest to least, I know that the greatest one is the first one, the next one is the second one, and then the last one is the third one. So your answer choice would be J. Okay, go ahead and watch this video. You can save it for the end or you can watch it now to see the importance of using very, very small and very, very big numbers, which is what we're talking about today. So this is what scientific notation looks like. There's a coefficient in the front times times 10 raised to an exponent. So a standard number like 700 can be turned into scientific notation by writing it as 7 times 10 to the second power. And you can prove this by typing it in the calculator, but you don't have to do it. It isn't necessary. Here's another number, 4,900,000,000 can be written as in scientific notation as 4.9 times 10 to the 9th power. So the whole point of doing this is so that you don't have to write all those zeros, especially as the number keeps growing or shrinking. So what do you notice? Look at these examples. So the first one says 100. If I write that standard 100 number in scientific notation, it becomes 1 times 10 to the second power. The next one is 4,321. If I write that in scientific notation, it becomes 4.231 times 10 to the third power, and so on. So some things that we notice is the coefficient, so that's the first number, is a number that is greater than or equal to 1, but less than 10. So notice how this first number, greater than or equal to 1, less than 10. Greater than equal to 1, less than 10. Greater than equal to 1, less than 10. Same thing here, same thing here. Greater than equal to 1, but less than 10. It has a decimal, but it still falls between 1 and 10, and it could be 1. All the numbers are multiplied by 10 raised to a power. So the exponent is your power. And lastly, the exponent is positive for big numbers and it is negative for small numbers. So here's some examples, some detailed notes on how to do this. And then we're going to go watch a video on the next slide. So go ahead and watch this video so that you can practice changing from standard to scientific notation. Make sure you write down with the video as it goes. Now here is some examples. So it says convert the following numbers from standard to scientific notations. These are the videos. These are the examples from the video. So you should have these answers from the video. So now you're going to try the next 4 problems in your form. After that, we will continue as a group. So now we're going to go the other way. So if we are starting in scientific notation, we're going to practice turning this into standard form. Go ahead and watch this video, and then you're going to put your answers into the Google form from the video. So here are the problems from the video. You're going to put these answers, the ones that into your Google form as a class, for the problems as a class. Now you're going to try some by yourself. So complete your form, turn it in, mark done. Make sure you signed in for attendance. If you need help, make sure you ask myself or Ms. Tess, and we can help you practice further on with scientific and standard notation and decimal notation.